Introduction. Yesterday, Roy was very happy as he was going for a picnic with his family. They all were traveling smoothly. Then suddenly a dog came in their way and his father applied hard brakes. They all felt a jerk and fell forward. Then Roy asked to his father that, "Why we all fell forward when brakes were applied?" Then his father replied him that, "It was due to inertia of our body." This means that while the car stopped, their body remained where it is due to inertia. Now, let's learn more about inertia and laws of motion. Objectives. At the end of this lesson, you will be able to understand Aristotle's fallacy, define law of inertia, define Newton's laws of motion, define impulse, know the law of conservation of momentum, calculate equilibrium of a particle, learn common forces in mechanics, define circular motion, solve problems in mechanics. Aristotle's fallacy. According to Aristotle, the Greek thinker, an external force is required to keep a body in motion. Let's understand with an example. A toy cart is at rest. When a boy pulls the handle attached to the cart, then the cart comes into motion. And when boy releases the handle, then cart comes at rest. Now, according to Aristotle, cart came at rest because there is no external force applied on it. But actually, the cart comes at rest due to frictional force of the surface, which opposes the motion of cart. Law of inertia. The inertia of a body is the property of the body by virtue of which it opposes the change in the position of the rest or of uniform motion of the body in the absence of external force. Inertia of a body is directly proportional to its mass. Any velocity once imparted to a body will be definitely maintained as long as there are no causes of acceleration or retardation, a condition which is approached only on horizontal planes where the forces of friction has been minimized. Let us take an example. In the case of a plane which is sloping downwards, there is already present a cause of acceleration. In the case of a plane which is sloping upwards, there is already present a cause of retardation. In the case of horizontal plane, there is a constant motion. Newton's first law of motion. Newton's first law of motion states that every body continues to be in its state of rest or of uniform motion in a straight line, unless compelled by some external force to act. If the net external force on a body is zero, its acceleration is zero. Acceleration can be non-zero only if there is a net external force on the body. Newton's second law of motion. First of all, we will talk about the momentum. Momentum of a body is defined as the product of its mass and velocity. P is equal to m into v. It is a vector quantity. The direction of momentum is in the direction of velocity. Its SI unit is kilogram meter per second. Newton's second law of motion states that the net external force acting on a body is directly proportional to the rate of change of its momentum. Its equation is given as: consider a body m initially moving with a velocity of u meter per second. When a force of F Newton is applied on it, its velocity becomes v meter per second after a time of t second. Then, according to Newton's second law, F is equal to mv minus mu divided by t. F is equal to ma, where a is acceleration produced in the body. Hence, the net external force acting on a body is equal to the product of its mass and acceleration produced in it. Example: constant force acting on a 8 kg mass change its speed from 2 meter per second to 3.8 meter per second in 25 seconds. If the direction of motion of the body remains unchanged, calculate the magnitude and the direction of the force. Let's see the solution. Let's take an example of Newton's second law of motion. Given values are: m is equal to 8 kg, u is equal to 2 meter per second, v is equal to 3.8 meter per second, t is equal to 25 seconds, f is equal to ma is equal to m into v minus u divided by t is equal to 8 into 3.8 minus 2 upon 25. Force is equal to 0.58 Newton. Because the direction of motion does not change but magnitude of velocity increases, therefore force must act along the direction of motion. Impulse. Impulse is defined as the effect of a force on a body which acts on it for a short interval of time. Impulse is equal to the product of force and the time interval. I is equal to F into T. If the momentum of a body gets changed from P1 to P2 in time t, then according to Newton's second law of motion, F is equal to P2 minus P1 divided by t. Impulse is I is equal to P2 minus P1 divided by t into t. I is equal to P2 minus P1. I is equal to delta P. Impulse is also equal to the change in momentum of the body. It is a vector quantity and its direction is same as that of change in momentum. Newton's third law of motion. Newton's third law of motion states that to every action there is always an equal and opposite reaction. Action and reaction are equal in magnitude, opposite in direction, and act on different bodies. A man rowing a boat with the help of oars, a ball is bouncing on the ground are the examples of Newton's third law of motion. Consider a pair of bodies A and B. Then FAB is equal to minus FBA. One of the two forces involved in the interaction between two bodies may be called action force. The other force will be called the reaction force. Conservation of momentum. Isolated system. A system is said to be isolated if there is no exchange of mass and energy between the system and surroundings. Conservation of momentum states that in the absence of an external force, the total linear momentum of an isolated system remains same or conserved. Explanation using Newton's second law of motion. When there is no external force F is equal to 0, then dP by dt is equal to 0. P is equal to constant, mv is equal to constant, m1 v1 is equal to m2 v2. Explanation using Newton's third law of motion. Consider an isolated system which consists of two particles of masses m1 and m2. Then total mass of the system is m is equal to m1 plus m2. Let a force F be applied on the system due to which F1 and F2 act on m1 and m2 respectively. If there is no external force acting on the isolated system, then F is equal to 0. d by dt of P is equal to 0. P is equal to constant. Hence, the law of conservation of linear momentum is proved. Assessment. Before proceeding further, let us know how much have you learned. Drag and drop the correct option. Equilibrium of a particle. When there is no change in the state of rest or of uniform motion of a body on which the forces act, the body is said to be in equilibrium. Concurrent forces are those forces whose lines of action intersect at a common point. The figure shows 4 concurrent forces F1, F2, F3 and F4, whose lines of action intersect at O. A body in equilibrium may be or may not be at rest. The condition necessary for equilibrium of a body under the action of concurrent forces is that the vector sum of all the forces acting shall be equal to 0. Lamy's theorem states that if three concurrent forces acting on a body keep it in equilibrium, then each force is proportional to the sine of the angle between the other two forces. Let F1, F2 and F3 be three concurrent forces in equilibrium. Then, according to Lamy's theorem, F1 upon sine alpha is equal to F2 upon sine beta is equal to F3 upon sine gamma. Common forces in mechanics. In mechanics, we encounter several kinds of forces. The main contact force in mechanics is friction. Friction. It is defined as an opposing force which is set up between the two surfaces in contact when one body slides or rolls or tends to do so on the surface of another body. It acts on both the bodies tangentially on the surfaces in contact and obeys the Newton's third law. Limiting friction. The force of friction between two bodies in contact when one body is in position to just begin to slide over the surface of another body. Static friction. The force of friction between two surfaces in contact before one body actually starts moving on the surface of another body. Kinetic friction. The force of friction between the surfaces in contact when one body is in motion on the surface of another body. Rolling friction. It is defined as the friction that comes into play when the bodies like ring, disc, sphere, or cylinder rolls or tends to roll over the surface of another body. Rolling friction is less than the sliding friction. Friction is a necessary evil. Friction always opposes the motion and energy is dissipated in overcoming the friction, but at the same time it is necessary because it helps us in walking, moving bodies and transmitting power. Methods of reducing friction. Friction can be reduced by reducing the value of coefficient of friction for the two surfaces in contact. This can be done in the following ways. Number 1. By polishing. Number 2. By lubricating using lubricants. Number 3. By converting sliding into rolling. Circular motion. When a body moves on a circular path, then its motion is called circular motion. And if a body moves on a circular path with a constant speed, then its motion is called uniform circular motion. Forces on the body is given by F is equal to ma is equal to mv square upon r. It is always directed towards the center of the circular path. Therefore, it is known as centripetal force. Some examples of horizontal circular motion are: Number 1. Vehicle taking a circular turn on a level road. When a vehicle takes a circular turn on a level road, the force of friction between the tires of the vehicle and road provides the necessary centripetal force to the vehicle. The maximum speed with which a vehicle can take a circular turn of radius r on a given road is given by V is equal to under root mu rg, where V is equal to speed of the vehicle, mu is equal to coefficient of friction. Number 2. Banking of roads. In hilly areas, circular turns are very frequent and sharp. Therefore, roads are made in such a way that their outer edge is slightly raised than the inner edge, so that sufficient centripetal force could be provided. If the vehicle takes a circular turn of radius r on a banked road with speed v, tan theta is equal to v square upon rg, where theta is the angle of banking. Number 3. Bending of a cyclist. A cyclist always bends himself with the vertical while taking a circular turn on the road, so that he could provide himself a sufficient centripetal force. Solving problems in mechanics. To solve a typical problem in mechanics, we should use the following steps. Step 1. Draw a diagram. Step 2. Choose a convenient part of the assembly as one system. Step 3. Draw a separate diagram which shows this system and all the forces on the system by the remaining part of the assembly. Step 4. In this diagram, include information about forces, that is, either given or you are sure about them. Step 5. If required, follow the same procedure for another choice of the system. Did you know? Sir Isaac Newton was born in 1642, the same year that Galileo died. He was born in a poor farming family. He was sent to study at Cambridge University in 1661. In 1665, Newton observed the fall of an apple. This simple incident prompted Newton to explore possibility of connecting gravity with the force that kept the moon in its orbit. This ultimately led him to the universal law of gravitation. 1 dyne of force is that much force which produces an acceleration of 1 centimeter per second square in a body of mass 1 gram. 1 gram weight of force is the force with which a body of mass 1 gram is attracted towards the center of the earth. The area under the force time graph gives the magnitude of the impulse of the given force in a given time. Summary. Let us summarize what we have learned. Gravitation is a natural phenomena by which physical bodies attract with a force proportional to their masses. The inertia of a body is the property of the body by virtue of which it opposes the change in the position of rest or of uniform motion of the body in the absence of external force. Newton's first law of motion states that every body continues to be in its state of rest or of uniform motion in a straight line unless compelled by some external force to act. Newton's second law of motion states that the net external force acting on a body is directly proportional to the rate of change of its momentum. Impulse is defined as the effect of a force on a body which acts on it for a short interval of time. Newton's third law of motion states that to every action there is always an equal and opposite reaction. Conservation of momentum states that in the absence of an external force, the total linear momentum of an isolated system remains same or conserved. When there is no change in the state of rest or of uniform motion of a body on which the forces act, the body is said to be in equilibrium.